We are going to be working on the rest of the notes for 8.1, 2, and 3. We completed the notes for 8.1 and 2, and we started 8.3. We're going to try to wrap that up today. We started out with 8.3 talking about maxes and mins, and we discovered that the maximum value is going to be in a situation where we have a parabola that opens downward because the highest value here, the vertex, is going to be at the highest point, and that's going to obviously be a maximum value. We're talking about the y value in each one of these cases. Okay, so the y value of this vertex coordinate here, the y value of the coordinate, is going to be the value of the min or the max. The minimum value, again, talking about the y value, is going to be whenever the parabola opens upward, because obviously the vertex is at the lowest point of that graph of the function. We get into a little more description and recognition of this, how we can recognize if it opens upward or downward in the next part here in core concepts. The graph opens up, okay, it opens up when a is greater than 0. You could also say that, looking at this graph right up here, this is a situation where it opens up. We're talking about ax squared. Okay, that's going to open up, and a is a positive number. Whenever you have a negative a, we'll say, let's write it in green so it kind of matches the description or the graph here. If a is negative, then that's going to open down. Okay, and that's what we see here. It opens down as long as a is negative or less than 0. All right, so that's going to be the case here. Whenever you have a negative out in front of the x squared, it's going to open downward. If you have a positive number in front of the x squared, it'll open upwards. All right, and then there's kind of a neat little thing that you can bring across from previous lessons with linear equations. When we had a linear equation, we had y equals mx plus b, and b was this constant that sat out here on the end. Sometimes you didn't always have one, but b was this constant that sat out on the end, and the relationship to graphing was that this was the y-intercept. That was the y-intercept. Well, when we're dealing with quadratics, a quadratic is going to be ax squared plus bx plus c. And so because we had to add this another term here with another x term, it took the place of the b now. So c is now the constant that sits out on the end. But the cool thing about that c is it's still the y-intercept. Okay, that's still the y-intercept of the graph. It's still where the graph is going to cross the y-axis. Okay, so C is, if you notice over here, C, that's still the point where that graph's going to cross the y-axis. So that's one thing that can help us when we're looking at graphing in relationship to the equation or the function itself. All right, so the y-intercept is still the C. All right, and then there's going to be something we're going to use this formula here, this negative b over 2a. We're going to use that formula to help us find the x-coordinate of the vertex and the axis of symmetry. The axis of symmetry is a vertical line, so it's obviously x equals something. And it is the x value in the coordinate of the vertex. And we're going to find it by plugging in the values b and a into this formula, negative b over 2a. All right, and that's the formula. It always begins with a negative. I had a student ask earlier, there was a little confusion about negatives. It doesn't matter if b is negative or not, it's still negative, and whatever b is, positive or negative, over 2 times a, positive or negative, whatever those two placeholders values signs are. Okay, so we have this axis of symmetry, and we have the graph here. The vertex and the axis of symmetry are related in that the x value of the vertex is also the equation for the vertical line for the axis of symmetry. All right, let's look at just reiterating the maximum min values here. We said as long as A is less than 0 or negative, then that means that it's going to open downward. And if A is greater than 0, which means it's positive, then it's going to open upward, and it'll be a min. So we have a max in this situation. We have a min in this situation here. All right, and we'll see that as we move along. And we'll turn the page. All right, the first things that it's asking us to do here on the first practice problems for this section is to determine the axis of symmetry and find the vertex of the graph. Okay, so remembering that anytime we have f of x, we could always replace that with y. So y equals this. Will probably help us in the second part of the process here. The first part, we're just going to find the axis of symmetry, and so we're going to find out the placeholders for A and for B, and then we're going to plug those into our equation. And A was the axis of symmetry, and the formula for that was going to be x is equal to the opposite of opposite of b over 2a. So let's fill in those values. We're going to have x is going to be equal to b. What is my b value here? B value is negative 10. A value is positive 1. Okay, so I'm going to plug in a negative b, which b is a negative 10. All right, and then we're going to have that all over 2 times a, and a is just simply 1. Now, 2 negatives are going to make a positive, so we'll have a positive 10. 2 times 1 is just 2, so we have 10 over 2, which reduces down to 5. So x is going to equal 5. And that is my axis of symmetry. It's also the x value in the coordinate for the vertex. So I'm going to find out what that vertex is, but I know that starting out, I'm going to put it right here, the vertex has a 5 in it for the x value. We just need to find the y value for this vertex. Okay? Now, the way we're going to find that, if I know what the x value is, can I find the y value? Yes. And what do? I just plug in the 5 back into this function or this equation, and it gives me the y value. Remember that this is still like the little number crunching machine. We've talked about equations being like machines. You put a number into the machine, it spits out a number. Well, the number you put in is an x value. The number it spits out is the y value. So y is going to equal x squared. Well, we're going to put a 5 in for x. So we'll have 5 squared minus 10 times 5 plus 2. Okay? And if I simplify this a little more, 5 squared is going to be 25. 10 times 5 is 50. And we'll add 2, so y equals that. And whenever I do my math in this, I'm going to end up with y equaling a negative 23. Okay, so my vertex is at 5 and a negative 23. And that's it. We just have to find the axis of symmetry, plug in the x value back into the equation to find the y value. All right, and now that you know how to do it manually, let me show you how to do it on the calculator. And as we mentioned before, the calculator is going to be your best friend whenever it comes to testing and checking your homework, because I'm going to use this calculator to find, I can actually use it to find the vertex and the axis of symmetry. But one thing we're going to just use it for to make sure we're doing or finding the right numbers is going to be our vertex. If I know that the axis of symmetry is 5, then I can plug in this equation into my y equals, and I can check the value at 5 and make sure that I got the right answer for the y value. So in y equals, I can put in x squared minus 10x plus 2. And I can go to the table. I don't necessarily have to go to the graph. I'm going to go to the table, so second graph will get me to the table. And I'm going to go down to the value for 5. And if you'll notice, the value for 5 gives me a negative 23. So I did my calculations correct. When you plug in a 5 for this function, you get a negative 23. Now, you could also find this vertex and the axis of symmetry by looking at the numbers in this y column. You'll notice these numbers are getting smaller and smaller and smaller and smaller till it gets to negative 23. Now at negative 23, it reverses and it gives me the same numbers on this side as it does on this side. If you thought about it and turn this sideways and put these numbers, isn't this a graph that's shaped just like a parabola? Right? The numbers here are getting smaller and smaller and smaller and smaller until I hit 23. And then they go back up. Negative 22, negative 19, negative 14, negative 7, 2, and then it goes positive, positive, positive. So this is basically the shape of your parabola using your numbers, and 23 is the vertex, and it's your lowest number. So if you're looking at your numbers there, you can obviously find out that 5 and 23 is your vertex just looking at the tables in this graph, or the table of this graph. Okay? Let's move on to number 2. Number 2, we're going to find our A and the B values. A is a negative 4 and B is a positive 16. Okay? Using those, I'm going to find the first part, A part of the answers, and that's going to be the axis of symmetry. And what that is x equals, and we'll just fill it in as we go. It's this negative b over 2a. So we're going to have negative 16 over 2 times a negative 4. Well, negative 16 over a negative 8 is what that would end up being. So negative over negative is positive. 16 over 8 is 2. So x simply equals 2. And that is the equation for the vertical line, which is the axis of symmetry. Now that I've found that, I can find the vertex. I'm going to take the equation y equals, and I'm going to plug in a 2 everywhere I see the x. So I'm going to have a negative 4 times 2 squared plus 16 times 2. And 2 squared is 4. Negative 4 times 4 is going to be a negative 16. Plus 16 times 2 is going to be a 32. So now y equals this. And if I do my math here, I'm going to end up with a positive 16. So my vertex is going to be at 2 and 16. Once again, if I wanted to put this into the equation y equals, put the equation y equals on my calculator, I could confirm that this is correct. I'd have a negative 4x squared, and I would add to that 16x, go to my table, look up 2, and the answer is 16. If you'll notice again, 16 is the largest number. Okay? What if I kept going? Well, let me go over to the x values here. If I looked here, I've got 16, and here is the negative. Here's 12 on both sides, down to 0 on both sides of 16, down to negative 20 on both sides, negative 48, negative 84. So this is a max. This is a max, and the vertex is 216. Max, if you look, it's a max because the negative in front of this 4 means that this points downward. So this definitely is a max at the vertex. Okay? All right, confirming that, we know our answer is correct. We can go on to number 3. Number 3 is, again, we're going to do this pretty repetitively, using the same process or method to go through the process or the steps here. we're going to solve for the axis of symmetry first. We need to know what the A is. We have a -2. We know what B is. That's a -8. So we'll plug those in for part A. Axis of symmetry is going to be x equals -8 over 2 times a -2. Well, that makes a +8 on top, but the bottom still stays a negative, and it's going to be a -4. So I'm going to have a +8 over a -4, which is going to give me a -2. So x equals a -2 is my axis of symmetry. Then from there, I can find the vertex. Let's do it in the calculator just so that we get some practice doing it that way as well. So let's go and put this in the calculator. Y equals, I'm going to clear that other function out. I'm going to have a -2x squared minus 8x plus 5. And then I'm going to go to my table, my second graph. It takes me to the table. I'm going to look at -2, and the y value at -2 is 13. So I know that the vertex is at -2, 13. And we'll work these out on our practices. I want you to show your work, but I just want to get you familiar with doing the calculator as well so that you can check your work. Obviously, if you just put down x equals -2 and the vertex is -2 and 13 on your practice papers, we're giving you those answer keys to make sure that you're doing your practices correct. So without showing any work, you're not going to be able to get full credit for these. So make sure you show your work. But just want you to get familiar with this calculator, that you know you can go here to confirm your answers. And then obviously on the testing time too, you can use your calculators to confirm your answers. Let's look at number 4. Number 4, A and B, we have a -3 and we have a +6. For the axis of symmetry, part A, we have x is going to equal -6 over 2 times a -3. And so we'll have a -6 over a -6, which gives us a +1. So x is going to equal 1 for the axis of symmetry. Means we'll have a vertical line at x equals 1, and our parabola will be symmetrical. Both sides of that line will be a mirror of each other, basically. All right. B, we're going to find the vertex of the graph. And here we're going to have y equals, remember you can always replace that with y. So y equals -3 times x, which is 1, plus 6 times 1, plus 1. So we have a -3 plus 6 plus 1. And if I do my math here, then y is going to equal a +4. So my vertex is at +1, +4. And again, we could put that in the calculator and we could check that value. Okay, let's look at number 5 and 6. And when this is just going to be where we're going to graph the function, and we're going to have to use some of our knowledge of finding the vertex, finding the axis of symmetry, and recognizing the y-intercept as well to help give us some points so that we can try to put this on the graph or on the grid here. The easy one, right off the bat, we can take this +2. We know that's our y-intercept. And so that being our y-intercept, we know we can go to +2. When we put a point there, we know the line's going to go through there some way. So that point we can go ahead and plot. Then let's find our axis of symmetry so that we know where we can draw the dotted line where our mirroring is going to happen. We know that the A and the B, we're going to have 3 and 6. So x is going to equal -6 over 2 times 3. Which -6 over -6 over +6 is just going to be a -1. So know that our axis of symmetry is going to be at x equals -1. That is my axis of symmetry. Okay? So now that that's there, I could go ahead and say, well, you know, if I've got a point on the right here, then mirroring that point, I know I'll have another one right there, because this is the mirror line. You know, we're going to have points on either side that are going to mirror each other or be symmetrical to each other. And so we'll have both of these points right there. But we need to find out what a vertex is. So let's look and see if we can plug in a -1 to find the vertex. Y is going to equal 3 times a -1 squared plus 6 times -1 plus 2. Okay? So we'll have -1 times -1 is 1. So we'll have, this is going to be 3 times 1 or 3 minus 6 plus 2. And so our answer here is going to end up being -3 and 2 or -1. So y is a -1. Our vertex is at -1, -1. So I'll plot that point. That is my vertex. And I can draw the graph now, knowing that it's going to go up somewhere in here, come through the vertex there, go back through that point, and then look something similar to that. Okay? So that's the graph of number 5. We're going to do 6 the same way. Okay? Again, on number 6, we can locate this right here. This is my C. It's also the y-intercept. So I know at -1, the graph is going to cross the y-axis from some direction. I don't know which way yet, but I know it's going to cross right there. I can find my axis of symmetry. Finding A and B. I can plug it in, so the axis of symmetry is going to be x equals, I'm going to have a -8 over 2 times 2. Okay, so negative makes a positive. 8 over 2 times 2, or 8 over 4, is going to equal a positive 2. So at x equals 2, my axis of symmetry is going to go through right there. That's going to be the axis of symmetry. And since I know that that is the line that mirrors or makes things symmetrical in my parabola, I can go 2 spaces to the right and plot another point that mirrors the one that I had for my y-intercept. All right, and now I need to find the vertex, so I need to find the y value when x is 2. So y equals this equation with 2 instead of x in it, 2 times 2 squared, minus 8 times x, or 2, minus 1. Okay, so I'm going to have 2 squared is 4, times 2 is going to be 8. 8 minus 8 times 2, which is 16, minus 1. All right, 8 minus 16 is a -8, and -8 and -1 would be a -9. So my vertex is going to be at 2, -9. And if I count down 1, 2, 3, 4, 5, 6, 7, 8, 9, you barely make it there on the graph. And now I know that my graph is going to be going through that point, down through the vertex, back up to that point right there. And that shouldn't be too difficult. We've been able to locate or to discover what the axis of symmetry is and the vertex already. We understand that that last number there, the constant, is going to be the y-intercept. And so that gives us enough points that we should be able to graph this. Without a calculator, we should be able to graph this, just given the function itself. All right, let's flip the page. We probably won't work all these examples, but we'll work several of them. Maybe we'll confirm some of them with a calculator too, but we'll work some of these just so we get an idea of how to do them. It's asking us to find out whether this is a min, or if the function has a min or a max. And then we got to find the value. Well, the value of a min or a max is the y value, right? It's the y value of the vertex. Okay, it's the y value of the vertex. So if I'm going to find the y value of the vertex, well, I have to use all those steps I did before. I've got to find the axis of symmetry, plug that x value back in to find the y value. But the initial question is to find out if this is a min or a max. That's pretty simple. In fact, that's very simple. Here, we have a negative sign. Which way is the parabola going to open, up or down? Down. So this is going to be like this. And if my vertex is at the point at which it changes directions here, is this a max or a min? Max, yeah. It's pretty easy. This is going to be a max. All right, so that part's pretty simple. We're going to have a max. Now, to find that max, that's where it's going to give us a little more work to do. All right, so let's get started here. Axis of symmetry. Let's find that one first. Find the x value, and then we can find the y value. I'm not going to write down my a's and b's at this point. We should be able to just look up there and start plugging these in. So x is going to equal the negative of b, which is negative 5, all over 2 times a, which is a negative 1/2. Okay? Well, that works out nicely for us because that's going to just become a negative 1 on the bottom. 2 times the 1 is a 2. 2 over 2, negative. 2 over 2 is just negative 1. And this is going to be negative 5. So I'm going to have a positive 5 over a negative 1, or just simply x equals a negative 5. Okay? So that's my axis of symmetry. That's not the final answer, but that gives me something to plug back into the equation so that I can find the y value. Okay, so let's find out what that's going to be. Y is going to equal negative 1/2 times a negative 5 squared, minus 5 times a negative 5 plus 2. Okay, we'll draw a little line here to separate these, make sure we don't overlap. We've got a negative 5 squared, which is 25. Negative 1/2 of that is going to be a negative 12.5. Okay, if you did the decimal form of that, or 12.5. All right, so I had 25 squared. I took half of that. I get negative 12.5. This is going to be a positive 25. Negative 5 times negative 5. And then we have a positive 2. When I do all my math here, y is going to equal 14.5. You can do that in the calculator, and you can find out that would be 14.5. If I were to put this in the calculator and put this equation in, go to my table, look at x equals negative 5, I would see that my y value is 14.5. Okay, so you can obviously confirm this one in the calculator as well. All right, let's do number 8. Number 8, this has a positive. This has a positive. So this graph is going to open up or down? Up. All right, so if that opens up, then what do we have right there? This is a min, or a minimum. Okay? Because the graph opens upward, it's a min. All right, so finding our axis of symmetry, x is going to equal negative 16 over 2 times 8. Well, that just simply is negative 16 over 16, or negative 1. Okay? We'll plug that into the original equation to give us our y value. Y is going to equal 8 times negative 1 squared plus 16 times negative 1 minus 2. So I'm going to have an 8, negative 16, negative 2. So y, when we do our math here, y is going to equal a negative 10. So it's a minimum, and it's at negative 10. Okay? On number 9, we may do this on the calculator. Number 9 here, we're going to have a negative number. So the negative means this graph opens up or down? It opens downward. So because it opens downward, this is a min or a max? That is a max. All right, and I'm just going to put this in the calculator. Since I know this is a max, I'm going to see if I can find in the calculator my maximum value. All right, if I turn my calculator on here, go to y equals, clear out the old one, I'm going to have a negative x squared minus 4x minus 7 and hit enter. I'm going to go to second table, and I'm going to look and see if I can find where I have the biggest number, right? The biggest number. Well, these are all pretty small numbers. They're all negatives. But look right here. Right here, I have the biggest of my negative numbers, which is a negative 3. Right? This is getting smaller, and this is getting larger until it gets to negative 3. Then it goes back to getting smaller again. So I'm getting smaller as I go away from negative 3 in both directions. Negative 3 is the largest number I have. We're looking for a max. So y equals negative 3 is my vertex and is the maximum value. Now, obviously, I can do all the work to show this. I just wanted you to see that in your calculator, you can also discover what this is. You can look at, too, the graph. If you look at the graph is going to give you a general location of where to start looking for that max or min. I'm going to start looking for it right here. What is that value on the x-axis? Negative 2. So this gives me an idea of where to look for my vertex, and then I can go to the table and say, well, let's go look around negative 2, and voila, there it is. Negative 3 is the value. Negative 2 was the x value for the vertex. Okay? All right, let's look at one more. Let's do number 11. Let's do number 11 here. On number 11, again, is this positive or negative? It's positive, and so we know that this graph is going to open up or down. It's going to open up. It's going to open up. So is this a min or a max? This is going to be a min. Okay, so we know that's going to be a minimum, and we know we need to find our axis of symmetry here. So we're going to have x is going to equal negative b, which is 6, over 2a, and a is 9. All right, so we're going to have a negative 6 over 18. If I reduce that or simplify that down a little bit, I'm going to have a negative 1 over 3. Okay? Now it's a fraction, so don't panic. It's going to work out, and I'll show you how this is going to work. Let's plug that back into the original equation. We have y equals 9 times a negative 1/3 squared plus 6 times a negative 1/3 plus 4. And really, these are going to probably start to cancel each other out because everything's going to be divisible by 3 anyway, right? So I'm going to have a negative 1/3 squared. It's going to give me a positive 1 over 9. So 9 times 1 over 9. Plus, and this is going to be a negative 6 over 3 or a negative 2. So I have to put that in parentheses, and we'll solve that in just a second, plus the 4. Well, 9 times 1 over 9 is 9 over 9, or just 1. Then we minus 2, and we add 4. And so y, final answer, is going to be what? 3. 1 minus 2 is a negative 1, plus 4 would be a positive 3. So my value for this minimum is going to be y equals 3. Okay? Y equals 3. And you can do these the same way. You can put these, find the axis of symmetry, plug them back in, find the y value. But I feel like these are enough examples for you to go on to get started on your practice. Hope this has helped you with 8.1, 8.2, and 8.3 notes so that you can do your practices. We'll spend some time in class working on practices tomorrow. Have a great day.